A 600 by 600 mm printer with CNC machine components and Clipper firmware for less than 2,000 euros? Sounds like overkill, and maybe it really is. The Venture XL from FYSETC promises a lot, but between theory and practice there's often a huge gap. So what can this printer really do? What hurdles will you encounter during assembly? And is this thing even worth it? That's what we are going to find out right now. Let's start with the basics. The Venture XL is a Core XY printer inspired by the Voron 2.4. But there's a thing, it isn't a 1x1 clone, it's an independent design created by FYSETC. The build volume, 600 by 600 mm. That's a serious beast. The frame consists of 40/40 aluminum framing, solid, heavy and extremely stable. Add to that CNC machined metal components at every important location. Inside, you've got a powerful duo of control electronics, an H723 microcontroller running at 550 MHz and a RK3568 quad-core processor powered by the Clipper firmware. The whole system is controlled via a crisp 7-inch HD touchscreen. According to FYSETC, the Venture XL can achieve print speeds up to 500 mm per second, with accelerations reaching a staggering 50,000 mm per square second. Whether or not that's practical, we will get to that later. But one thing is clear, the hardware is on point. The stepper drivers, big steppers TMC 5160 combined with a few additional 2209 drivers deliver plenty of torque and reliability. The heated bed is segmented and zone controlled, which saves energy. The printer is fully enclosed and includes the integrated StealthMax air filtration system. And if you're considering future upgrades to IDEX or AWD, no problem, the mainboard already has expansion slots ready to go. Before this thing even can think about printing, you've got to put it together first. Assembly begins with 3 enormous boxes. Altogether these weighed around 64 kilograms, about 140 pounds. That's not just heavy, that's a statement. From the moment you start unpacking, it's quite obvious you're not dealing with a typical DIY kit here. This is serious hardware. Important note up front, the fully assembled Venture XL at nearly 1 meter in width will not fit through any standard doorway. Be sure to decide exactly where you want it to be permanently placed, or you will be forced to take it apart again, or you have to break through some walls or something. Apart from that, everything is neatly packed, clearly labeled and well organized. Unfortunately though, there's no sorting box or organizer provided. And anyone who's ever had to hunt through tiny plastic bags on a cramped table knows exactly how quickly that can become frustrating. On the bright side, each screw type includes extras, which is a small detail I genuinely appreciate. And the CNC machine components, apart from one exception, which we will discuss later, they're phenomenal. Honestly impressive, rich, anodized colors, precise machining, no sharp edges, and exact tolerances, exactly the way you wish every printer to be. These components easily match the quality of the Cibo AWD Trident kit, and the large display fits the printer perfectly. Honestly, a small 5-inch screen would look completely out of place here. The 7-inch display is much more fitting for a printer of this scale. Another small but genuinely clever detail, the printer stands on cast iron industrial casters. What's great about this? These casters can be retracted via a geared mechanism. This means that in normal operation the printer sits rock solid on its feet, no wobbling and no rolling away. And if you ever need to move it around, there's no problem, you can simply lower the wheels again and you can easily reposition the printer. At over 60 kilograms, wheels like these really do make perfect sense, trust me. The print beds themselves are milled rather than rolled and they feel solid. One small drawback, the heating mats aren't pre-attached, so you have to do this yourself. Here's a tip, use high temperature silicone and run a thin bead around the edges once you've attached the mat. This prevents the mat from peeling at the edges over time, something that can happen quicker than you think. Important detail here, make sure everything is completely grease-free before you start. First, clean the aluminum plate and then carefully apply the magnetic sheet afterwards. Remember, grease is your enemy here. The side panels come covered with protective film that's thankfully easy enough to remove. I've encountered kits where the protective film tears every 2 centimeters, but that wasn't the case here, which was a nice relief for me. If you have issues though, just warm up the film slightly with a hairdryer. It will peel off much easier that way. One point we really appreciate is the power supplies. This kit includes brand name power supplies, no generic, no-name parts here. Anyone who regularly watches our videos knows we often replace unknown power supplies purely for safety reasons. Luckily, that's not necessary here. Well done, FYSETC. Another detail we absolutely love, the kit includes a soldering iron, complete with a special tip for embedding threaded inserts. Why don't all manufacturers do this? It's not only time-saving, it also feels like someone genuinely thought this through. It's precise, these small touches that make a big difference. Then there's the Z-axis motors. These aren't your typical steppers, they are planetary geared motors with a gear ratio of 27:1. This ensures that the gantry won't drop when you power it off, so you can confidently turn off the printer without worrying about the print head crashing into the bed. The downside of this, once you've installed the belts, you can't move the axis by hand anymore. The holding torque is enormous, which isn't always a benefit, especially when trying to manually adjust positioning during assembly. These motors are actively cooled, with heat sinks and a small fan. Of course, in high chamber temperature environments, this might only help marginally, but under normal operating conditions, it definitely ensures stable motor temperatures and extends the life of drivers. Speaking of stepper drivers, FYSETC actually includes spare TMC drivers in the kit, something I haven't seen from many other manufacturers, so thumbs up for that. That said, I've also come across a different perspective. Someone noted that the motors don't really need active cooling when run at the factory set to A, with a temperature delta of around 25 degrees Celsius. They also reported that both of their motors' fans failed with a short time. The main board is also extremely well designed. The CAN bus wiring is neat, cable quality is excellent, and everything feels solid and reliable. During our testing period, we didn't experience any single connection drop, which proves the kit quality. Clearly, FYSETC hasn't cut corners on that point. But now, let's get to the flip sides of things. And that begins with the manual. I will be frank here, it simply feels incomplete. Some screws are incorrectly labeled, graphics don't match reality, and important assembly steps are entirely missing. It gives the impression that they built a prototype first, then created the CAD model, and directly derived the bill of materials from that. But actually assembling the final kit again afterwards, seems nobody ever did that. If they had, obvious errors like excessively long screws or inexplicable changes would have immediately been spotted. And it doesn't stop there. Some parts aren't even mentioned in the manual at all. In our version, for instance, there wasn't a single word about how to install the internal LEDs. This might be addressed in a future version of the manual, but as of now, it's something to watch out for. The cable routing is also sometimes hard to follow. And right here, major problems can occur. A good example is the DC converter mounted on the Z-axis extrusion. If you simply lay the CAN cable on top of the box, the printhead will collide with it. If you route the cable too tightly in the front, the exact same problem occurs. The only functional solution is to route the cable loosely, giving it just enough slack to move flexible past the box. Is this an elegant solution? Definitely not, and honestly poorly thought through. Even though the hardware itself makes an extremely high quality impression, negligence like this can completely spoil the assembly experience. The frame uses blind joints, and once you've attached the corner brackets, certain screws become completely inaccessible. This means you will align everything perfectly, realize one corner doesn't fit properly, and you have to disassemble several parts again. We also noticed the issue with cable length, so the motor cables are labeled, but in our version the C cables from the front set motors were simply too short. We had to route them differently. According to FYSETC's GitHub, this issue has already been fixed, but definitely double check yours before assembly. In general, FYSETC has begun documenting many errors and tips on their GitHub, which is a great step forward. Another problem, the set idler pulleys. FYSETC replaced the original toothed idler pulleys with smooth bearings. On paper that might sound logical, but they didn't adjust the geometry accordingly. The result? The belt no longer runs parallel, and that's not a minor issue. Here's a graphic showing exactly what we mean. Thanks to Esoterical for the analysis. To actually fix this properly, we had to swap or request replacement CNC parts. Instead, we simply reinstalled toothed idler pulleys by ourselves, and voila, the issue is immediately resolved. While we were at it, we made several other modifications as well. Yes, this means our review isn't 100% stock anymore, but honestly, what good is a printer that meets paper specifications but can't reliably perform in real-world conditions, right? Fortunately, all the problems mentioned so far can easily be addressed. It might already be resolved in the next production batch. Besides the motor cables, some of the supply wires are excessively long, making it nearly impossible to neatly organize the electronic box. The floor plate lacks enough anchor points. Just a few additional holes for cable ties would have made organizing this mess way easier, but it's unfortunate that such details weren't considered from the start on. Speaking of the electronics box, it also shows some clear oversights in design. Take the hinges, for example. Initially, we thought they had been installed backward, but no, they are intentionally installed this way, as it's the only way the lid closes properly. Visually, however, it doesn't match the rest of the printer since the door hinges are mounted differently. Admittedly, this might seem like nitpicking, but it's noticeable. Let's be clear, this is a commercially available version, not a beta, not a pre-release test version. Issues like these really shouldn't happen at this stage. Someone told us their kit was implicitly supplied as a beta test, and they thought those were being sold as pre-release kits. To be honest, they didn't agree with that approach either. Those kits should have been tested way more before anywhere sold. But in our case, we ordered a regular retail version, so from a customer's perspective, these kinds of flaws simply shouldn't be present. Otherwise, assembly is doable, but definitely not suitable for beginners. If you have got experience, then there is no problem. But if you have never assembled a printer yourself, honestly, you should stay away. Or at least get someone experienced to help you out on it. As an additional resource, Nero3D did a live stream of his own assembly process. You can check that out in his VOD to get a feel for the complexity that is involved in this build. One decision we wouldn't classify as an outright error, but rather a poor choice, is the included hot end. It's a bamboo-like model, it's compact with a short melt zone and, in our opinion, significantly underpowered in terms of heating performance. For a printer of this scale, that's a major issue, because we're not talking about printing small benchies here, we're talking about serious throughput. Large surfaces, long print paths, big volumes, and for that, such a minimalist hot end simply isn't enough. That's why we immediately swapped it for a Rapido Ultra High Flow version. As expected, the difference was massive. Consistent flow rate, clean print quality and no drop-off in heating performance halfway through a print, exactly how it should be. Maybe worth mentioning here, since the carriage is based on the Crydteam CNC design, it's actually quite easy to adapt different toolhead setups. It gives users some welcome flexibility. Ideally, FYSETC should have put their best option forward from the start, but at least the platform makes upgrades relatively painless. And then there's the extruder. By now, you probably know our relationship with the CW2. We are simply never going to be close friends, so we immediately removed it and replaced it with a G2E. We did try, honestly. We made a few test prints with the original setup, but it was the same story as always. Poor extrusion quality, inconsistent layer lines, and as soon as we pushed higher flow rates, print quality completely collapsed. This issue has consistently plagued every setup we've ever had with the CW2. That said, we know that there are users who report good results with the stock CW2. Also, one person told us they are running it as supplied, including the integrated IGDA style gear set, and aren't seeing any extrusion issues at all. So, to be fair, This is our personal opinion, but not an isolated one. A lot of people in our community have shared similar frustrations, whether due to badly printed parts, cheap BMG clones, or simply misadjusted tension screws. Your mileage may vary, but it's something to be aware of. We also upgraded the port cooling fan. Out went the stock fan, replaced by a Devil Design 10,000 RPM model. Why? Quite simple. If you're using a printer without auxiliary cooling fans, you absolutely need powerful airflow during short layout times. Otherwise, you will never achieve clean overhangs or sharp edges. And yeah, that's exactly what this new fan delivers. Exactly how big the difference is, you will see in the upcoming XXL fan comparison video. So don't forget to subscribe to our channel so you don't miss out on that one. Additionally, we replaced the supplied stealth burner version equipped with the cutter tool with the standard version. While the cutter is theoretically an interesting feature, in practice it isn't actively used yet. And that's precisely the issue. The point where the cutter blade would eventually engage, a small ridge is created between the printed parts. Even this minimal edge can cause filament to snag when loading or unloading. And if you know the stealth burner, you know that quickly assessing the filament channel isn't exactly easy, so quickly inspecting the filament path is just another option here. Therefore, our clear recommendation, if you're not actively using the cutter, just remove it. The standard stealth burner version works reliably and creates less hassle in its current state. And here's an extremely important point. The heated bed runs directly on 230 volts mains voltage. Even a single mistake during installation can be life-threatening. Therefore, connecting this part absolutely must be done by a qualified electrician. No exceptions. When you have finished assembling absolutely everything, and I mean everything, you're finally ready for the next step about 20 hours later, the initial setup and commissioning. And at this point I have to give credit where it's due. Well done, FYSETC. The software side is really well prepared. Clipper firmware comes completely pre-installed, and the ideal scenario, your system will boot up immediately without any need to flash individual components or deal with operating system installations. If something doesn't start up right away, don't panic. Clipper's error messages are usually quite clear and informative. If you need SSH access to your system, the username and password are simply FYSETC. Once you have access to main cell and the status screen no longer shows any errors, I strongly recommend working through the Voron initial startup guide. The link, as always, is in the description down below. This guide helps you verify basic functions such as motor connections and stop triggers and proper homing. Just the essentials. Our personal tip: immediately upgrade your cartographer to the touch module version. The difference it makes is huge. To set it up, simply follow Ricard's instructions on the wiki. His documentation is fantastic. Shout out to him. If you aren't familiar with the setup yet, the touch-enabled cartographer ensures you never have to manually set your C offset again. We've implemented this on all of our printers, and frankly, we've never want to go back. By the way, adaptive bed meshing is integrated by default since the latest Clipper update. However, make sure it's correctly configured in your start G-code. You probably don't want your printer to probe the entire bed before each small print job. Additionally, we've tweaked our configuration a bit further. For example, we moved the park position to the front of the printer. By default, Clipper parks the printhead in the very back corner during filament swaps, which simply doesn't make sense with a printer of this size. We've also activated adaptive heating of the bed zones. This feature lets Clipper automatically detect which bed segments are actually in use, heating only those sections. This saves power and reduces stress on your electronics. Quick note on that, we configured the heated bed segments to heat up sequentially rather than simultaneously. If all 4 bed zones were to heat up at once, there's a high chance your circuit breaker could trip, especially if other devices are connected to the same power line. Lastly, we've optimized our quad gantry leveling routine to minimize C-hop in its second pass, saving a bit of extra time. Then finally it was time for the first test prints. See offset adjustment? Completely unnecessary, thanks to the touch-enabled cartographer. First off, we wanted to see how much flow rate can our setup really handle. So we performed a classic max flow test using the Rapido ultra high flow hot end paired with a ESAN PLA Plus at 220 degrees Celsius at a stable extrusion flow rate between 15 and 40 cubic millimeters per second. Conservatively, we comfortably achieved around 30 cubic millimeters per second. Short-term peaks might go slightly higher, but our main goal was to ensure consistent melting performance during prolonged movements over distances up to 600 millimeters and print times spanning multiple hours. After all, with large format prints, consistency is key. We then transferred these settings directly into our slicer and printed a classic Benchy without even calibrating the filament beforehand. And the result was surprisingly good. Honestly, we anticipated significantly poorer quality, especially for small, intricate parts printed on such an enormous machine, but the print turned out really well. Even fine details were clearly defined. Next up, we printed a 450mm tall cylinder simply to check for any visible signs of C-bending. And guess what? The layer stacking was consistently clean. The only noticeable issue, the set seam. It's a bit pronounced, mainly due to a lack of retract calibration, but nothing too dramatic though. Because we were curious, we then tried printing a lithophane. For those who aren't familiar, lithophanes are images printed as reliefs that become visible when backlit. We scaled it down slightly and compared it directly with a print from a Bamboo P1S. And honestly, the print quality was nearly identical. Apart from some small blobs around sharp edges, again due to the lack of retract tuning, there were barely any differences. And keep in mind, we're talking about printer with a build volume that's 600% larger. Then we brought out the big guns, quite literally. We printed a vase in vase mode during full build height with a 0.6mm nozzle at 35 cubic millimeters per second. Sounds good initially, I know, but honestly, it turned out to be a bit ambitious. After a few rounds, it was clear cooling performance was insufficient for overhangs. The cooling airflow simply wasn't enough to stable layers at the end, and we had to dial back to the pace. One key lesson learned here: if you're printing at flow rates between 30 and 35 cubic millimeters per second, ensure your layer times are at least 15 seconds long. Anything shorter and the previous layer is simply too hot, it results in poor definition. Although the hot end fan is powerful, it cools very specifically, only at the exact point it is aiming at. And when your hot end is racing across the print, that airflow moves away just as fast. Static auxiliary fans, so-called aux fans, are the solution here. These fans blow consistently across the entire print surface, independent out of the toolhead position. Unfortunately, the Venture XL doesn't come equipped with such auxiliary fans. Whether this might become available as an upgrade in the future remains to be seen. For now, we have equipped our setup with a 10,000 RPM fan from Devil Design, but of course this doesn't fully replace a true auxiliary fan setup. That said, it's also fair to point out if you're printing large parts on a printer of this size, there's a good chance your layer times will naturally exceed 15 seconds anyway, especially when printing multiple objects or complex geometry sequentially. Still, if you're doing single wall prints or smaller details at high speed, cooling remains a limiting factor you will need to address. Which brings me to the point that can't be emphasized enough. With a 0.6mm nozzle, your hot end is almost always the bottleneck, not the printer mechanics themselves. The advertised 500mm per second might be achievable during rapid travel moves, but realistically it's not more than a marketing number. Nobody needs that speed particularly, nor would you meaningful benefit from it. It's also important to recognize that the AB motors on this machine are more powerful than typical ones. They're physically larger and run at 48 volts. This gives the system plenty of headroom for high-speed travel. We've spoken with some who run travel moves at up to 1000mm per second and 20,000mm per square second without any issues. But even in their case, printing accelerations are kept around 5000mm per square second, simply because flow rate, not motion. is the limiting factor. However, in the next few weeks we plan to run a max speed test to see where the actual performance limits lie. If you're interested in those results, let me know in the comments and we will be sure to include them in our next video. Right now we are running moderate accelerations of around 15,000 millimeters per square second. Whether a print takes 37 hours or 40 doesn't matter to us at all, because components stay healthier, the mechanics last longer and you get significantly less wear and tear overall. Something far more valuable for us than shaving off an hour of print time. Finally, we decided to test something decorative, a Groot from Marvel. We wanted to see how the printer handles organic shapes and fine details. And the result, apart from minor stringing, it looks absolutely fantastic. And if anyone thinks my printer does better, keep in mind the context here. We are talking about a 600 by 600 mm Core XY printer. It delivers print quality that can easily compete with much smaller, highly tuned machines, and at a price point that's almost absurdly affordable in this category. For us, that's genuinely impressive. With that, let's slowly move towards our final verdict. Can we truly recommend the Venture XL to everyone? No, no. And that's perfectly okay. The Venture XL isn't a plug-and-print machine, it's a genuine self-built printer in both of the best and most challenging senses. Especially given the current shortcomings and the assembly instructions, you will need solid experience assembling 3D printers and some technical understanding. Ideally, you've already built 1 or 2 machines by yourself. Important point, we've replaced the toolhead, so our setup is no longer stock. That means we can't provide an in-depth comparison to the original configuration. However, the few test prints we made with the stock combination of the CW2 extruder and what we consider an underpowered Holland were enough to draw a clear conclusion. This toolhead is in its default form not future-proof for large-scale, high-speed printing. If you plan to get this printer, definitely budget for some upgrades in this area. What we absolutely have to criticize though is FYSETC's quality control. The issues we have mentioned would be totally fine in a beta kit, but not in a product that's officially marketed as a retail version and explicitly aimed at professional users. FYSETC clearly has great ideas and provides mostly high quality components, but when it comes to the final stretch, the so-called last mile, they are still falling short. Maybe we are just looking at it too critically, but you know, the classic German way, everything needs to be precise and flawless. But seriously, if you want to play in the professional league, the product has to be fully polished, no excuses. If your project regularly exceeds 350 millimeters, so you're beyond the classic Voron format, then the Venture XL is spot on. If you're mostly printing smaller parts, you might be better off running 2 smaller machines like a pair of Vorons or other printers. That way, you gain efficiency and flexibility. Now, if FYSETC ends up releasing an official IDEX upgrade soon, the whole picture shifts dramatically. Suddenly, you don't just have a large format printer, you have an incredibly versatile platform. And for that, the Venture XL already offers a ton of potential. There's plenty of room for expansion, whether that's IDEX or even the completely new INDX system from Bondec. It's also worth noting that there is a generous clearance about the bed, giving the gantry and toolhead ample space to move. This could make implementing a tool changer significantly easier, potentially even without sacrificing any build volume. What's that exactly? We don't know much yet, but if everything works out, we will be part of a beta test. And of course, we will show you all the details of this exciting new multi-filament system. So stay tuned. Our final verdict, despite all the criticism, remains clearly positive. The Venture XL is an impressive printer for advanced users. If you know what you're doing, you will get a powerful tool here with a huge potential, even if it needs still a little bit of polish out of the box. If you like the Venture XL and you're now in the mood for even more unique 3D printers, be sure to check out the LH Stinger, currently one of the fastest printers of 2025. Seriously impressive what that thing can do in terms of speed and acceleration. Or maybe you're more into compact machines, but still want robust CNC hardware and AWD, then I highly recommend the AWD Trident from Seabor, a compact beast with high precision. And if you're made it all the way to this point, thank you very much for sticking around. If you enjoyed these in-depth reviews, feel free to hit the subscribe button and let us know in the comments what you'd like to see next. One last thing, since we are still a small channel and not monetized by YouTube yet, you can support our work on Patreon or as a channel membership on YouTube. Every bit makes a difference and helps us keep this thing and keep content going. Thanks very much and see you in the next video. Peace.